This is gonna be the van from heck, or close to it, close to the center of the earth. And I got so I got the computer pulled out. Got a wiring diagram I'm looking at here. What was going on? I had a P0340 code, and what was happening was, you know, I assumed the distributor, and being that I had replaced the distributor in some of these older vehicles before, and I did check my wires for power, 12 volts, ground, and sort of signal, sort of. So the thing was, I didn't thoroughly check my signal side, and I did inform the customer that I didn't do a good job of checking that, and I should have changed some things up. So I'm making some accommodations here. So I just want to show you what I got with the signal side, because I had a result to hooking up the oscilloscope here on the signal side, and it's supposed to be a square wave, and this is what I got. You know, I got nothing but straight lines here. It's supposed to be approximately 12 volt square wave, but I'm not getting that. And I zoomed in on one, and that's what it looks like crap. The signal's going up, and immediately it's making a conscious effort to go up, but this is just basically an ignition waveform. It looks like I'm just pulling up like an ignition event, or or some distortion. What looks like. Ain't that smart, man? So here's the thing. I'm gonna show you what I did to narrow down that, you know, it's not the distributor, because I really was cussing at O'Reilly's, not literally, but to myself. My sister called, so I was, you know, I was like, you know, O'Reilly's kind of screwed me over here, but that's totally not the case. It was me. It wasn't them. I apologize. I still patronize you. The good patronize, not the bad. So, let me know what. Let me show you. So here we are on the inside of the vehicle. We got the distributor here. This is the second one I put in, and here is the signal wire. The signal wire is going to be a brown and a white. That's what I'm tagged on at the PCM there. We have our 12 volt and our ground. So when I back probe the signal wire here, I got that straight line. However, when I disconnected it and took my lead here and back probe the sensor, I got a square wave. And I'm going to show you that real quick. All right, change of plans. I want to show you that shortly. I just want to show you what there's an ant right there. I'm going to show you what I did first. Before, I'm just going to backtrack. That's what I'm going to do, because I'm pretty much at the final stage of determining that I'm just going to replace the computer. So that's what we're at right now. So real quick, the wire that we were working on was the brown and white wire here. Here's the wire going to the cam sensor. I did test for ground. I got my power probe here, and so I'm backtracking here. I got the power probe, and I was just doing a resistance value test and see if they would short the ground. Now, typically a G101 or a ground is going to go from, you know, within the wiring harness is going to go from here to a ground. I mean, this was like an instant repetitive issue. As soon as I replace the distributor, clear the code, it comes back immediately with the pending code. So I'm thinking that there's a short somewhere within the wiring, but that doesn't seem to be the case. So we're here on the third pin out on the C connector, and I don't have any resistance value. So if there's no resistance value with it disconnected, then there's obviously no short from here going out to my cam position sensor. Now, I did do a resistance test that I probably might do when I get everything hooked back up, but the resistance value that I got was 34 ohms. Typically on a switching circuit, I should have known that, because typically on a switching circuit, I get a value of like 1K ohm, something around that, like 112K. But on this particular circuit, it was 34K. Now, I did go to the crank position sensor signal, and I'm pretty sure they basically absorb a square wave. Man, I'm pretty sure Chevy's pretty consistent with that. It's not like an AC and a Hall effect type system. This is just a Hall effect type sensor. So it utilizes a square wave, not an oscillating wave signal. So since we're utilizing a square wave, let me see if I can get this back up here. Since this is utilizing a square wave, I'm pretty sure it's going to have the same type of input from the PCM. So I did check the resistance value from the third pin, which is going to be on this side, down, up. So the third pin, 1, 2, 3. Even though it's not like a legitimate ground, where the resistance value is. Let me see if I'm on the right one. Not sure I'm where I need to be. So yeah, 1, 2, 3. 1, 2, 3. Yep, so I got 34 ohms here, and this is my cam position signal input to the PCM. 31 is going to be the crank position input. 31, it's a 32 pin, so I'm going to go one below, and I got, if I can get a value, it'll come up. That's weird. Hold on, make sure. I hope I got everything hooked up properly. I just recently got a value, so we're on connection hooked up on the PCM. I guess I had a poor connection, but regardless, like I say, typically I'll get like a 1K ohm, and it's kind of like I don't know why it's in and out with getting the value. I guess because my ground here, but the housing is grounded, so I was mindful of that. But I was getting a 34 ohm value on the signal side for my cam position sensor signal going to the PCM. Now the crank, I don't know why it's not cooperating, so I can get a good signal on that, but that's not at fault at the moment. We're worried about the cam position signal. I was just trying to compare the two signaling sides together, but obviously that's not working out. I did get a value once. Strange, I'm not getting an appropriate value. Now I'm going to hook everything back up, and I'm going to show you within the vehicle I still got the 34 ohm resistance value, and I'm going to show you with the connector hooked up appropriately and with it not hooked up appropriately. You're going to see the difference in the waveforms. All right, oh yeah, also if you're trying to determine which wire you're dealing with, you have several options. One option that I generally employ is the safest route, and I just use a test light. This is one common method probably a lot of people use. I got my wire isolated here, even though I'm dealing with a bunch of wires. I got wiring diagrams, and we know we can't trust those. So I'm going to use a test light. It's basically going to send an extremely low amperage amount of voltage through the wire, so insignificant to the point where it's not going to short any wires out. You're not going to cause anything to catch on fire. I mean, let me just show you. I mean, once I short the light out, it just lights up. It illuminates. So that's me shorting the test light. So you're basically going to get the same thing on the other end here. So what I do, I basically just send voltage through my wire here, which I'm down here on the third pin on this connector. Send it down through there. Go inside the car and check for voltage. I mean, everything's disconnected. There's no 12 volts that generally go through this source here. So when I check that wire for voltage, I should see 12 volts displayed. Alright, I'm back in the vehicle before we check the oscilloscope here. And here's the wire. I got my power probe here, and it's just going to make noise once it determines that I'm on 12 volts. Because I got this tip voltage here. I know you're probably not going to be able to see it. The screen is so bright there. But once once there's voltage detected on this wire, it's going to make noise and beep. So let me just go here. It will also beep for ground also, but you know, we're not doing that. Here's the ground signal here. Well, it's not doing anything because the harness is disconnected. But I'm looking for 12 volts. There's no 12 volts on the ground. There's nothing. The ground is not even grounded. But there's my 12 volts on the 12 volt side here. But mainly, being that the wire is not matching, this is a pink wire. The wire I'm supposed to be on doesn't normally supply 12 volts. This brown and white wire here. So if this is detecting 12 volts, then I know I'm on the right source here, and actually it's producing 12 volts. Let me check this one again, because yeah, this is grounded actually. Yeah, I guess normally when it's off, it's going to detect the ground because it's probably getting a back feed from a 12 volt source or whatever. But that's normally 12 volts. But I digress. And if you want to confirm that you're on the right one and it's producing 12 volts, simply disconnect your voltage source, which I'm going to do shortly. So simply just remove it, go back in the car and see if that same wire produces 12 volts. Alright, so we're back in the car. Here's our brown and white wire. We have the power source disconnected from the test light, and it should not produce any voltage. So I shouldn't see that red light illuminate, and it's not. So I know for a fact I was on an appropriate one. And that's generally what I do to determine if I'm on the right wire, if I got a lot of wires or whatever. That's the safest route. You can also use a test meter. This is a voltmeter, and I'm just looking at volts here, just saying 12 volts, and it's just making a lot of loud noise to indicate that, hey, you have 12 volts here. So, all right, I'm gonna get set up here on the oscilloscope. I got the 20 volt DC and go push start here on a 20 was a 50 millisecond per division time base here. So I'm going to show you what it's like with it connected. This is not going to be a super connection here. I just want to connect it enough to get a signal. I'm just going to go in it back there. I'm going to start it up. And here's the signal. I'm going to take it out and make sure I got adequate voltage. So I'm going to go on my 12 volt side here and watch it climb, just to make sure my connections are working appropriately. So yeah, it climbed up. Now I'm going to go back to my signaling side here. And this is all I got on the signaling side. I'm going to take this out. Take the pin out here. Now I'm going to go right into the signaling pin and check the wave out. Look at that. Uh-oh. I got a square wave. If I can get it in there. There we go. So I got a good square wave. So lesson learned, I should have taken that extra step in diagnosing this vehicle. I put 2 distributors in here, and they're timed right. It was just obviously that I thought that the that Hall effect unit in there was dropping the signal down, and that ultimately wasn't the case. So live and learn, even though we have the resource. I mean, I figured common, shoot apart at it, 2 distributors, and I was wrong. And I'll say, you know what? It's either me or the part, and it was me. so I should have properly diagnosed it. But based on the condition, how superficial, the unappealing, the last distributor look, I feel comfortable putting this one in there, even though it's aftermarket, and the other one lasts like 38,000 years. So I'm just gonna have to let them know we should put a computer in here. Oh yeah, I forgot. Let me do a resistance value at this wire here and show you that I do have 34 ohms on this signal wire, and there's no actual ground pulling the signal down, but the resistance, the low resistance value on the PCM. Alright, I got the power probe back out here, and we're gonna do a resistance value. There's 33 ohms right there. Let's see if I can get that. Hold on, there's a reflection there. Oh shit, my light done died. Let's see if it'll pick up. Can we get it? There we go. There's a 33 ohms. So it's close. We have to take in consideration some other variables. Maybe it had like a more of a legitimate ground, being that, you know, the actual connector is hooked up, but it's extremely close to the value I got out of the PCM, and that confirms that there's something wrong with the PCM. It's pulling down the signal, and I have to replace the computer in here. You gotta take my word on this one. I mean, it was obvious after I diagnosed it like I was supposed to, but I still feel a lot better knowing there's a distributor in here. At the same time, though, I shouldn't have shot apart at it, you know. But I worked with the customer. I told him what was going on, and I told him that I'm making accommodations. So they're gonna be fixed like they're supposed to. There's no wire issues with this. It's just the computer. I'm gonna get that computer in here, and they'll be fixed. But hit that link, subscribe to the channel, stay informed, have the reassurance of my work. See you next one.